So problem 3 asks you to evaluate this expression. First of all, how would you read this problem? If you were to read this expression, what would you say? Yeah.
3/4 to the third power.
3/4 raised to the third power. Great. So, what did you try on this? Go ahead.
So 3 times 3 times 3, or 3 to the third, and then over 4 to the third.
Okay. So what you did, and I'm going to kind of leave some space here, is that you ended up multiplying 3 times 3 times 3, and also 4 times 4 times 4. First of all, why? Why did you make that choice?
Well, that's just how I learned it. Like, so if it's to the second power, you do 3 times 3. So
Okay.
So forth.
Sure. So you multiplied 3 by itself 3 times, because that is what 3 to the third power is, right, by definition. You multiplied 4 by itself 3 times, because that's what 4 to the third power is, by definition. And so my only question, if you multiply 3 times 3 times 3, you do get 27. If you multiply 4 times 4 times 4, you do get 64. So my question is, why do we get away with multiplying just the top by itself 3 times and just the bottom by itself 3 times? How come we can take this power and apply it to the numerator and denominator separately? Yeah. Okay, the parentheses. What function are the parentheses serving here?
Multiply.
Okay. Okay, right. Multiply all the... So here's, to piggyback on that idea, the parentheses are indicating that this 3/4 is grouped together, and whatever is happening to one part of this fraction is also happening to the whole fraction. So this whole fraction is getting cubed, multiplied by itself 3 times, raised to the third power, right? So here's how I think of it. If we all agree, and I think we do, that raising something to the third power means multiplying it by itself 3 times, then 3 to the third power is 3 times 3 times 3. 4 to the third power is 4 times 4 times 4. What is 3/4 to the third power? 3/4 times, there's where I'm getting at. 3/4 times 3/4 times 3/4. And so we've turned this exponent problem into a multiplication problem. And now we know, now that we know how to multiply fractions, based on what we talked about earlier, how do you multiply fractions? Straight across. So we're going to multiply 3 times 3 times 3 straight across the numerator, and multiply 4 times straight across the numerator on top, straight across the denominator on the bottom. So I wanted to add that intermediate step because that explains why we get away with just applying that power to the numerator and denominator separately. It's because raising a fraction to a power, or raising anything to a power, is the same as multiplying that thing by itself repeatedly. This is not the only time this semester. What I'm going to strongly encourage you to replace an exponent problem with a multiplication problem, because applying exponents willy-nilly inside parentheses will get you in big trouble later on down the line. So to the extent that it's possible, always rewrite an exponent question as a multiplication question, because multiplication is easier to think about. And we do get 27 over 64 as our final answer.